Welcome to talk number 2. Get the most out of testing with Spring 4.2. We have 2 guys speaking today. So I'm the guy who wrote the code, and
I'm the guy who wrote a book about integration testing.
So let's get going. Just a quick intro, talking a bit about ourselves. My name is Sam Brannen. I'm a Spring Enterprise Java consultant at a company called SwiftMine in Zurich, Switzerland. I founded a couple years ago with some colleagues. And I've been a Java developer for over 17 years. The main reason I'm here today is that I've been a core Spring Framework committer since 2007 and the lead for the Spring testing support in core Spring. Also created a recent alias for annotation, which you might see in some places in the code. I'm a Spring trainer, obviously speak at conferences, and I'm a co-lead of the Swiss Spring user group. My company, just a bit about us, SwiftMine, so we're experts in Spring and Enterprise Java in general, not just core Spring, but Spring portfolio, Java EE, software architecture, best practices, code reviews, those kinds of things. We like to help people get a nice proof of concept up and running and help them sort out their architecture. You find us in Zurich, online on Twitter, and on the web, of course, as well. So, end of you.
Hi, I'm Nicolas Fränkel. I'm a developer and an architect. Depends on who I'm talking to, because right now, yeah, if you talk to project manager, you should be an architect. But for you developers, I'm also a developer. I've been working as a consultant. I'm also do some teaching and training. I have a blog, and I am also a book author. I'm very proud to have been the first one to write about the Varden web framework. Who knows about Varden? Oh, guys, come on. OK. So you should definitely have a look if you want to do some web UI and have really component-oriented stuff, event listening, then you should look at Varden. And my latest book is about integration testing. I try to sum up my experience with integration testing, and there are 2 chapters dedicated to Spring. And now back to Sam.
So, what we plan to cover today, oops, not the black screen. We're going to start off with just an introduction to an application that we're using for the demos, the Spring Events app. Then we're going to talk about the new features in Spring Framework 2, basically the new testing features, focusing on that. Then we'll go into some discussions on JUnit versus TestingG. And then we'll look a little bit about what you can do with integration tests with Spring Boot as well as with Spring Security. And then at the end, we'll have some tips and tricks and some basically experiences we'd like to share with you guys.
Excuse me, could you raise the volume a little bit?
Can the volume be raised any, or should I? Is that any better, or is that worse?
More.
I can only speak, sorry. Yeah, is that testing, 1, 2, 3? Is that better? Good? Okay. So now I'd just like to see a show of hands. Who uses JUnit? Wow, lots of people. Who uses TestingG?
Be proud, guys, be proud.
Nice. Who uses JUnit and TestingG, just out of curiosity? Okay, interesting, okay. So if you're here, we assume you use Java and Spring, so we won't ask that. Who's using one of the Spring, like say 3.2 versions? Spring 3.2? Yeah. Who's on Spring 4? More? 4.1? Fewer? 4.2? Anyone? Okay. All right, so who's using Spring Boot? That's another big question, yeah. Spring Boot, okay, lots of hands. Who's testing with Spring Boot? Some of the same people? Okay. And Spring Security, who uses that? Okay, and who tests with Spring Security? Or do you just assume it does its job? Okay, right. Assumptions can be good or bad. So the Spring Events app, basically, it's just a simple Spring Boot powered application created with the starter page. Basic POJO domain model just with an event. So a Spring event is basically a conference event, so it just has like a name, location, stuff like that. Transactional service layer. There's also a security applied to it for method layer security. Spring Data JPA repositories for our data access. And then in the web tier, we have annotated Spring MVC controllers, REST controllers, and Timely for the view with Spring MVC. Then on top of that, of course, we have Spring Security again for the method layer in the service, and then also for controlling access to particular URLs. So if you want to check out the code later, it's on GitHub on my account as Brannen Spring Events, and now I'm just going to show you how this thing, or what this thing looks like when it's actually running in the browser. So we've got that. I can hopefully launch it up with boot here using Gradle for the build. That'll take a few seconds. Starting up an in-memory database for us as well with some sample data already pre-populated. So now if we switch over to the browser and go to localhost 8080, we have this simple Spring Events application. We're looking at the HTML view basically with time leave. We see that we also have JSON support here, so this is just going to perform a GET request. And we see that we have some JSON representation of the events there as well. And if we click on a particular event, we could get one particular event. So we have some GET requests there. We could also create a new event. Here we have Spring Security popping up. Standard default form login, and we could, for example, something we've already typed, Spring12GX, Washington, D.C., create a new event, and we see that that works, and now that shows up here as well. And if you're looking at the code and interested in it, there's also form validation built in as well. But we're just going to focus basically on how we can test an application like this, right? So we have all the layers. We've got the web layer, we've got data access, we've got service layer, we've got security, we've got Spring Boot, and we want to see how we can test that. So now we'll dive into what's new in Spring Framework 4.2. First up, at alias 4, I mentioned there's a new annotation. Basically, this allows you to do a couple of different things. Allows you to define aliases within an annotation. You'll see that within core Spring and things like at request mapping, there's now a new path attribute there, so you can say path instead of value, and you can do this kind of alias stuff on your own. But then what's more important for developers is what we call composed annotations. You might have seen that if you participated or attended one of my presentations in the past, showing how you can have attribute overrides, and now we'll see with that alias 4, you can actually have explicit overrides. So in the code here, with the events application, we have annotations like at get, at post, and stuff like that that have more semantic meaning for an at request mapping with the method set to get and stuff like that. Jürgen hinted at it last night during the keynote, Spring Composed, so we're going to be looking at providing some pre-composed annotations in Spring 4.3, and if you want to check those out, try them out, or maybe even come up with some of your own, feedback is welcome, and contributions are also welcome. So you can check that out also on my GitHub page, Spring Composed. That might later move to the Spring projects, but for right now it's my pet project there. So before 4.2, this is basically what I showed you guys last year. Composable annotations can override attributes in meta annotations. So meta annotation is just an annotation on your annotation. It's kind of like inheritance with Java classes, but not really supported by the JDK, but Spring supports this kind of stuff. So in the past, it was purely convention-based, basically just based on the name of the attributes and the types, and you could also run into potential naming conflicts, which we'll see in a minute. Another thing in the past, prior to Spring 4.2, is that you couldn't override the special value attribute. So with a convention-based approach, we have something like this. We have our own custom transactional test annotation, so we want to reduce duplication within our test suite, where we have the same test configuration all over the place. We want to have at context configuration and at transactional, and just use those on a lot of tests. So we come with this at transactional test annotation, and we specify here this locations attribute. It's the same as what's declared in context configuration itself. So this is based on convention again. The name is, does anyone see that? Let's see. Is there a green beam? Okay. At the top we have locations attribute, and then we have redeclaring that, and then when we use this in the code on our own tests here, we have at transactional test, that's our annotation, and the locations just it's seen as locations and context configuration by Spring, so that's based on the convention. And that works nicely as long as you don't have any conflicts. So here we have another example, similar to what we had before, but we've added an additional annotation. So instead of just having context configuration present as a meta annotation, we now also have test property source present as a meta annotation that was introduced last year in the testing support. So, thing to note about these is they both declare an attribute named locations of the same type, a string array. So then, when we have our custom annotation here, at transactional test with locations, it's now ambiguous. Which one are we talking about, or which one should be overridden? So if we use our at transactional test annotation on our own test class, like we have here in the bottom, then Spring's not going to know which one to override. What would happen actually at runtime is that it would work when Spring looks up the context configuration, and it would fail when Spring looks up the test property source, because it would try to open that XML file as a Java properties file, so that would fail. So that's what would have gone wrong prior to Spring 4.2. And now post 4.2, with the use of @alias4, we can have composable annotations that explicitly override attributes and meta annotations, even transitively over multiple arbitrary levels in the annotation hierarchy. And any attributes that effectively override the same annotation attribute will be considered aliases as well, just like with @alias4 within an annotation. So with this, we can also avoid these potential naming conflicts because we can be explicit. And in fact, we can override the value attributes. That adds some new features. Things like Spring Boot, for example, are taking advantage of that in their testing annotations there. So here we have an updated example for 4.2, what we were trying to achieve before, but now actually able to achieve that. So again, we have at context configuration and at test property source as meta annotations. And then we have now at alias4, where we're declaring that the first one here is an explicit override for the locations attribute in the context configuration annotation, and we're calling it whatever we want. So now we also have the power to rename things however we like. We can call it XML files, we can call it Groovy scripts, depending on how we're using it. It doesn't really matter. And then we have another one here, prop files, which is an explicit override for the locations attribute and test property source. So now we just have some new power. You can use this in your production code. You can also use this in your test code, beginning with Spring 4.2 and more importantly with Spring 4.2.1 with some improvements there. So then when we declare it on our test class, XML files and prop files, the first one's going to begin seen as locations in at context configuration, and the second will be seen as the locations in test property source, so no problems there. Has anybody seen that stuff before at alias4? Anyone? No one? Okay. So.
I always used embedded databases,
yeah.
and I didn't know about the name. Why do I require it if it works out of the box? Why should I care about the name?
Well, in the simplest case, that's true. So who here is actually using embedded databases? Like H2, HSQL, stuff like that for your testing? Maybe you're using it and you don't know if you're using Spring Boot and testing stuff like that. Okay, so basically with the name, by default, it's going to have one called TestDB, or potentially a data source, depending on how you set it up. But the reason that you should care about it is that you can run into problems if you have your data source config imported from multiple locations. So let's say you have your test data access config, your test data source config, either as an XML config file or as a Java config file, and you're using Spring's embedded database support. So then by default, it's going to have just a default name. And then if you have different use cases, so different scenarios you want to test, so different integration tests, maybe extending from different classes, importing different config stuff. If two sets of classes import the same config, then they're basically going to be asking Spring to create that database again, right?
I don't agree. I mean, let's say that I define my database bean as prototype, then it will get created each time I ask this bean, right?
Well, yes, the bean will get created. So but the bean is actually the thing that's connecting to the embedded database, right? But what does that have to do with the database? So Spring doesn't actually create the database for you. Spring just allows you to configure how you want the database created, right? And in the end, Spring's going to give you back a data source, right? So allowing you to get connections to that embedded database.
Mm-hmm.
So basically what I'm saying there is that it's not going to create a new one, right? It's just going to connect to an existing one. So if you say, create a database or connect to this database that's embedded called TestDB, and then another part of the code says, I want to talk to the same one, then they're going to end up talking to the same database. It's not going to create another one.
Are you sure? Could you please rephrase so that I really understand?
So that you really understand. Yeah, so basically what I'm saying here is all about the JDBC connection URL, and if you look at the documentation for these embedded databases, they're going to say this is how you create an embedded database, and if one doesn't already exist, it's going to be created for you then, and then you get back a data source right to that. So the same thing, the other side, the next test it runs and it reuses the same config, it uses the same identical configuration, the same database name, so it's going to ask for the same embedded database in the same manner, but the driver is going to say, aha, this one already exists in the JVM, so it's just going to let you talk to that one. It's as if you had an Oracle database. Just because you define the JDBC URL connection string, it's not going to create a new Oracle database for you, right? But a lot of times people run into issues where their tests start failing when they have different configuration importing the same data source config. And the only way to get around that is to come up with unique names. So unique names for databases, some support's been there all along, at least for defining your own name. If we go back to Spring 3.0 when the support was introduced, in the embedded database builder, so with Java config, you could have set your own name. You could have set it something random or unique, however you wanted to. And in 4.2, we've added support for generating a unique name. So I would actually argue that's now the best practice. If you don't have multiple ones, then you don't care what the name is anyway. And if you do have multiple ones, then you probably wanted to actually have different databases. So keep that in mind. Same's true for embedded database support with the JDBC namespace. As of 3.0, subtle feature most people didn't know, you define an ID, which should typically be something like data source or data source 2 or something like that. And if that's present, that would be used as the name of the database. But then if you import that XML, obviously it's not going to be unique. Then you have two tests basically trying to access the data source database. So in 4.2, we've brought the XML namespace in line with the Java config option here at the builder, so we can also set the database name explicitly if we want. You can even do that with something like a spell expression or property placeholder, something like that if you wanted to. And generate name is also there as well, so you can just set it to true. So now we see some quick examples to make this easy to understand. So here we have a data source. This could be our test data source config, for example, in Java config, a bean using the embedded database builder, and just invoking generate unique name true. Again, in XML, same thing, like you've probably seen in the past. JDBC namespace, embedded database, and now with this new feature here, generate name equals true, then you don't have any issues if you're importing that in multiple places within your test suite.
Sam, does it work with file-based databases?
File-based databases. So the answer to that would be no. At the moment, all of the embedded database support is just in memory, right? So not persistent mode. It's not going to actually save the stuff to the file system. There's a Jira issue open for that to basically add support for that in the future. So Spring might look into doing that. Just keep in mind, though, you don't actually have to use the embedded database namespace if you want to create your own. You can create it however you want. Just look up the documentation for H2, HSQL, stuff like that. Another thing with the Java config variant, there's some other options there, some other plugin points, extension points that you can use with the embedded database builder that aren't used by default, but you can basically change how the connection is set up and stuff like that. Connection URL. Okay. What up to now? Spring cleaning. So what's gone away? You might have been aware in the past there was this transaction configuration annotation, been around since Spring 2.5. That's been deprecated in 4.2, basically because we now allow @rollback to be used at the class level or @commit. We'll come to that later. So now instead of defining the default rollback semantics with the @transaction configuration annotation, you can just do it with @rollback or @commit. In addition to that, feature's been around a pretty long time. @transaction itself, the @transactional annotation from Core Spring has support for qualifiers, so you can just basically define the qualifier straight in the @transactional annotation. Another feature that's been around a long time, the assert throws class has been was deprecated in 3.x and is now gone in 4.2. So if you had been using that and you upgrade and your code doesn't compile, just switch to something already provided by your current testing framework. So for example, if you're using JUnit, just use @transactional expected or potentially the @rule expected exception variant that actually allows you a lot more power. And with TestingG, you can use expected exceptions, right? More than one, yeah. So Extension points, just like to talk a bit about some of the low-level changes in 4.2 for the testing framework in case anyone's interested in really digging in or basically customizing it on their own. So we see the context cache, the thing that's responsible for caching your context across your entire test suite to make the test suite run faster. So the application context, that's now a public API with a default implementation. You can also plug in your own. So other internals like the default test context, default bootstrap context, and default cache-aware context loader delegate. These things are also now public, and you can basically extend them if you need to. So the test context bootstrapper, which actually does all of the groundwork behind the scenes, is also now responsible for building the test context, so that allows you to even create your own kind of test context for some kind of other special needs. Spring and JUnit. So who here has used the @run with Spring JUnit 4 class runner? 4 people. I don't believe that. Okay. Who's ever tried to use the Spring runner and some other runner with JUnit? Yes. And were you successful? Hurts. Yes. So it's actually not possible, right? So to run 2 runners at the same time with JUnit. So in Spring, for the core integration testing support, we have in JUnit, right? We have the Spring JUnit 4 class runner, serving the community since Spring 2.5, 2007, quite a long time. But you can't combine it with other runners. So some other third-party runners, maybe you wanted to use something like the Mockito one or the parameterized one from JUnit. Wasn't possible. Some people came up with their own solutions and posted them online. And now in Spring 4.2, we have official support for Spring out of the box to do this. I'd been waiting because I was hoping there would be a way to do it with one single class, with one single rule to rule them all. But it's unfortunately not possible. So with Spring 4.2, we have 2 rules that you have to set up if you want to go this route. There's a class level 1 and a method level 1, appropriately named. And you can then use any other JUnit runner you want. So you can use the Mockito one, maybe something from Cassandra or parameterized, etc. So the way you set that up, use annotations from JUnit. So we have at the top @class rule, and then we're specifying a static field of type Spring class rule. Name doesn't matter, just instantiate a new one. And then for the method level support and before and after that kind of stuff, we have the Spring method rule annotated with @rule. That is an instance field, right? And the name, again, shouldn't matter, just has to be of that type. So just basically copy and paste this code. Sorry, there's 2 of them, but that's how it works. But it does give you more power, allowing you to do things like we have here. So we see the top @run with parameterized from JUnit, and then we can then have parameterized test support with loading an application context, with transactions, with running SQL scripts, all that good stuff you'd expect from Spring, and with any other runner, maybe your own custom runner. So hopefully people find that useful. Next up, who writes web applications? And keep your hands up if you test those web applications.
At the web layer.
Yes, at the web layer. And who writes, who uses the Spring MVC test framework? So mock MVC, that kind of stuff. Anyone use anything else like Selenium, HTML unit? Okay, so good combination. So we'll see that in Spring 4.2, we have some new features that have been available as a side project. Basically, we have first-class support for both HTML unit and Selenium within Spring MVC test. This is initially a standalone project. You might have seen it. Rob Winch developed it and talked about it in previous talks. Now incorporated in 4.2 in the Spring test module, basically allowing you to have stuff like page-based web app testing without actually deploying to the server container, so it's going to be much faster, right? And you can also use the Selenium support, for example, with Jeb if you're into a more groovy DSL style of testing. So you can test your full pages, right? So not just the interactions with your controllers, but also what's generated, right? The HTML that's generated by those, the forms that are within those, the structures of those, and also JavaScript as well. So here, I'm not going to go into a whole lot of detail. There's a nice new section in the reference manual that explains how to do this. There's also some sample applications from Rob Winch you can find online. But basically, if you wanted to use the HTML unit support, you would need Spring test, obviously. And then you're going to need the HTML unit dependency as well. And then to set that up, there's a builder API. There is the appropriately named mock MVC web client builder. So you want to create an HTML unit web client, but that is internally using mock MVC. So what it's going to do, instead of sending requests using HTTP over the network to a real browser, or to a real client, real server running, it's going to run that all through the test dispatcher server that's configured for you behind the scenes with mock MVC. So just like you use Spring MVC test to test your controllers, this is doing the same thing, but the HTML that's generated by that is going to get routed back through HTML unit. So again, then this is not going to work with something like JSP, but it'll work with stuff like time leaf, free marker, that kind of stuff. So everything that can be rendered outside of the server container. So just like in the Spring MVC test, we're probably going to use the TestContext Framework to load our application context with @context configuration, specifying @web app configuration, making sure we have a web application context, wire that in, create a reference to our web client here, and then in the before method, we can use the mock MVC builder's web app context setup. Sorry, that looks like a copy and paste there. That should be the mock MVC web client builder there instead of the mock MVC builders. But basically, you're going to create your web client like that. Typo, ignore that. So similarly, with the Selenium support, if you want to use that, we're going to be using a web driver instead of the HTTP web client. So just like before, configure your web application context with the testing framework, and then in the before method, use the mock MVC HTML unit driver builder, and basically passing in the web app context setup. So there's some more options here with this builder. If you're interested in those, just check out the Java doc or check out the advanced sections in the reference manual. So that's it, just kind of an overview. If you already know how to use Selenium and HTML unit, then it should basically be a breeze. This basically just ties into Spring MVC test framework so you don't have actual real HTTP connections. Some odds and ends, some smaller features. So reflection test utils has been augmented. You can now get or set static fields, including constants. AOP test utils. This is something that not a lot of people run into, but occasionally can come up. So AOP, right? Who knows what AOP is? Aspect-oriented programming. So basically creating proxies, adding advice, augmenting your code, right, runtime. So Spring creates proxies for you when you have stuff like transactional, at repository and stuff like that. And if you're using a mocking framework, for example, something like EasyMock or Mockito, I think it's more prevalent, or these issues are more prevalent in EasyMock. Basically, it's going to create a proxy that's going to dynamically implement the thing you want mocked. And if you have that configured as a bean in your application context, and the interface is annotated with that transactional or something like that repository, and you have Spring configured to proxy those kinds of beans, then Spring will proxy your proxied mock, if that makes sense. So then your mocking framework might have a difficult time finding the mock because it's hidden behind a Spring proxy. So if you run into a situation like that, you can use the new AOP test utils. This basically allows you to find the actual underlying target object independent of how many levels of proxying there are, as long as they're Spring proxies. @dirty's context. So who's heard of that? Okay, a few people. So it's kind of like or analogous to SQL. So you have like a dirty read or something like that, or basically dirty interaction with the application context. It means that in your integration test, you did something that modified the application context in a way that would make other subsequent tests fail, right? So you've basically changed the state. So in the past,
should you do that? Should you change your context during your integration testing? It seems to me like it's very bad things to do.
it can be a code smell, right? So there's a couple of different situations. Sometimes you're intentionally doing it, and then when you're the good citizen, then you would want to use an after mode, which is actually what is originally designed for. So originally, @context was designed for people who knew they had to change the state in order to actually test something, to make their tests actually cover what they needed. And then they said, okay, I know I messed it up. I know I messed up the state, and I want to not hurt my colleagues, right? So I want to say, I dirtied the context. Please clean it up after me. Take it out of the cache. Create a new one if someone else needs it. And that's actually kind of a good, healthy scenario. These new features are actually for the bad code smell scenario, where you on a project and maybe someone refactored and reorganized the packages, and then you first then realize that some of your tests are failing intermittently, or only if you run the entire test suite, because some test method somewhere in your 2,000 tests changes something in the application context and nobody knows who changed it. So that's the bad code smell, and I've been on projects like that. We kind of moved packages in the past, but if we didn't have time, this allows you to basically a Band-Aid approach. You can say, I don't know who's causing the problem. My test runs by itself, but I run it in the test suite, it fails. So I need a new application context before this test runs. You can do that now with before method, before class, and before each test method modes with add dirties context. But again, as Nicola was saying, that's actually a code smell. So if this comes up and you use this, you should probably create an issue in your issue tracker saying, we need to address this at some later point and figure out who's actually, or which test is actually causing the problem. But again, that's there in case you do run into a problem like this.
Thanks.
Yep.
So about reflection test utils. You know that if you do proper object-oriented design, you should use the most narrow scope possible for your methods and your fields. And of course, sometimes it's meaningful to have access to those private stuff because the public API might give you a heavyweight object, or you have to do more stuff, and you want to test the internal. In this case, you have two solutions. The first solution is to widen the visibility. And in fact, Guava acknowledges that, and it provides you with the visible for testing annotation, so that you say, okay, it should be private, but probably I make it package protected so I can access it in my test package. The other way is to use reflection, and then you will be very happy to have the reflection test utils, because if you use reflection by hand, you have to take care of all the exceptions and stuff like that. So if you know about transactional stuff, you also know about the default behavior of the Spring Testing Framework regarding transaction. And by default, it rollbacks everything. So that might not be what you want. And if you still want to commit, you will say rollback false, which is kind of semantically not very funny. So now you have the commit annotation, which does exactly rollback false, which does commit, which is more senseful. You also have the inline SQL annotation. So before, when you use SQL annotation, you could reference a script. Then you could run it before you test. For some one-liner, it's overkill. You don't want to write, or you might not want to write a single line, put it into a SQL file just to call it. You just might want to drop a table. And in this case, it doesn't make any sense to create a dedicated file. So they added a new attribute called statements, where you can run inline SQL. Just take care that in this case, this statement will run after the script that you might reference, because the annotation might use an inline SQL plus an external file. Also, if you use Spring MVC tests, you might know about the result handler. So basically, a result handler can do anything with your result, and there is one provided out of the box. The only thing that it did previously, it logged the result. So it was nice, but it logged it on system.out with no choice of configuration. So now you have additional methods. So you can use your proper logging framework, or you can pass an output stream or a writer. So you might want to pass system.err to have it in red in your console and something like that. So this is an example of the SQL statement. So those annotations will be processed sequentially. So the first that will pass will be the drop table. And then the second one, as I said, first you will run the script, test schema, and then it will run the statement. So this is just a little gymnastic to have in your mind to understand in which order they will pass. But it's very useful. Here, regarding the result handler, we configure our mock MVC to drop each time there is a response to write into the system.err. Very, very useful. It costs you nothing, so you might as well use it. Which brings us to our next point, the JUnit versus TestingG war. And I'm afraid I am in minority here.
It would appear so. Not so much of a war. We just want to kind of highlight some of the differences. We let you decide which one suits your needs best.
So first, let me remind you that TestingG was the first to implement the annotations. Because, you know, JUnit had this nice monopoly, and they were very happy. And when Java 5 came, it was a long time ago, right?
It was?
Yeah, they did nothing. JUnit was not upgraded to make use of annotation. So one guy decided, OK, let's use annotation on the test framework. And then came TestingG. So we should praise TestingG for that, because then it made the genuine folks, you know, just move and do some upgrade.
Encouraged.
Also, TestingG is much better than JUnit because it has a richer life cycle. Basically, with JUnit, you only have before, so it will run before each test method, and before class, so once before the class. TestingG adds many more hooks, like, OK, you've got the same. Then you've got the notion of group. You can group your test methods, and you can run methods before a specific group or after, and before a whole test suite. So yeah, we can do better. Also, and for me that is a killer point, JUnit is meant to test unit tests. So you don't have any kind of ordering. That would be very strange. That would be an anathema to JUnit if you had ordering test method. With integration testing, then you might want to order your method, and that is a good thing. And TestingG provides you that. And finally, TestingG also provides you with concurrent test execution.
Yeah, so thank you. Not really in defense of JUnit, we just kind of point out some of the things on the other side. As you mentioned, the unit in the term JUnit and all of the XUnit frameworks is actually for unit testing, so focusing on one thing. One key thing to note there, in terms of runtime semantics between JUnit and TestingG, the first thing you could notice is that JUnit actually instantiates your test class for every single test method that it runs. That means that no state is saved between executions of test methods. That can be seen as a pro or a con. If you want to save stuff between, then you're kind of at a loss, and one hack or one way around that is to create a static field and store it in there. So that's one case you could say where TestingG is better. It actually instantiates the instance once and keeps that instance while it runs all the test methods. But again, on the other side, with JUnit, it's kind of the harness there is basically a safeguard to make sure that your tests truly are independent. But again, you have to just keep in mind how it works. In terms of lacking ordering, that's correct. Prior to Java 7, we were all lucky that the JVM would return the methods in the same order they were declared in the test class. So people kind of depended on that. With Java 7 and above, the method order returned by reflection is no longer guaranteed, so those kind of tests would fail. But there is a fix, sort of, so to speak, a workaround in JUnit. You can use the @fix method order annotation that allows you basically to specify the order of your methods. You could come up with some kind of grouped order if you wanted, but mostly you would just do that alphanumerically, having like step 1, step 2, step 3, and stuff like that. So it's achievable in JUnit, but just not the same thing and not the primary goal of the framework. In terms of the runners, I mentioned that before. You have to have a single runner, right? But then if you're using rules, you can overcome that. And a lot of modern frameworks, including Spring, we're now more modern with 4.2, right? The frameworks provide their runner or a rule-based alternative to that. And with JUnit 5, you might have heard a bit about that. So coming up, we hope to basically expand on some of these extension points and improve there. And we'll talk more about that later on. So Spring Boot tests. Just a really quick overview of some of the features there. With Spring Boot, you're not talking about unit tests. If you're writing unit tests, just like with Spring, you're going to write your unit tests just with JUnit or TestingG, maybe using some mocks, stuff like that, easy mock Mockito. You don't want to actually rely on your application context from Spring or JPA or Hibernate or stuff like that. That would then be an integration test. So whenever you're testing the features of Spring Boot, that will by definition be an integration test. So first up, we have the @Spring application configuration annotation from Spring Boot. That is meta-annotated with @context configuration from core Spring. And the thing that makes it different, what's special about it, is it has a specialized loader for loading the application context for your tests that provides the magic of Spring Boot. So some of the features you would expect with, YAML support in addition to properties and the notion of the environment and ordering of properties files and all that kind of stuff. So you get that with the Spring application context loader and some other features there as well. Then, so this is for the standard, I would say standard integration test with Spring, but just with some Spring Boot power on top. Another layer above that is what we'd call the fully loaded layer, meaning that your Spring Boot application will actually be started, right? So Spring Boot's already going to be some kind of embedded mode, right? You have like embedded Tomcat or Jetty or Undertow, right? When you actually run it. And you can actually tell Spring Boot to start up a test, an integration test. I would even go on to say that's probably more like a system integration test because you're actually deploying your whole application in the container, in an embedded Tomcat server, for example. So to do that, you would again use the @Spring application configuration annotation, but you would add an additional annotation that says run in fully loaded mode. And the first one for that, first option there is the @integration test from Spring Boot. So that's going to actually start up your embedded server. With that, behind the scenes, there's an integration test properties listener that allows you to add test properties to the environment. That actually came before the support that was introduced last year in Spring 4.1 of the testing framework. So in core Spring test module, we have @test property source that allows you to define property sources and inline property values for your tests. And in Spring Boot, they have similar things. So with the @integration test annotation, you can actually put some inline properties there. The difference is that the Spring Boot variant allows system properties to override the test properties. And in core Spring, the test properties always win. Slight subtlety there, but you might find that useful. In the past, previous versions of Spring Boot, you could have added the core Spring @web app configuration annotation to a test with @integration test, and that would have said, I want a web application context that I could inject into my test as well. And in later versions, I think 1.2.1 or something like that, maybe. The man in the back, he authored it. Yes, sounds good. @web integration test annotation, that basically takes the place of using @integration test with web app configuration, and it moves away from the test properties listener model, and it has its own test context bootstrapper behind the scenes that adds the Spring Boot magic there. So just keep in mind you have some options. Again, at the top, standard integration test. If you want your Spring Boot application to actually start it up, maybe you have an embedded one that's not actually running in Tomcat, you could use that integration test. If you have a web application, REST application, then go the web integration test route. And later on we'll talk about some of the pros and cons you could run into there. Last but not least, I always like to point this out. You should basically understand what Spring Boot's doing. Okay, it does maybe too much, you can't understand everything, but for your testing scenarios, you need to understand what is it do I want to test, right? Do I want to test the repository layer? Do I want to test the service layer? Do I want to test the MVC layer, the REST layer? Or do I want to test all of it together as a system integration test? Or do I want to test all of it together running in the deployed embedded container, so running within Tomcat, right? So the first would give the options for testing individual layers, but with Spring Boot magic there behind the scenes, and the fully loaded ones would allow you to do the so-called end-to-end integration testing. Maybe you're talking to an embedded database instead of the real database, but otherwise you have every layer of your application with JPA, Spring MVC, security, all of that running in Tomcat. So hopefully take a look at this a little later on, or maybe we could even jump to a demo now. So I have a test repository config annotation that basically shows you how to limit the scope. Maybe we haven't actually looked at any code.
Might be a good idea
Good time.
at this point.
So
Do you want to see code?
Yes. Anyone want to see code? Yes.
No, nobody wants.
No coffee?
Yeah,
Better than code?
coffee might be a good idea.
Okay. So I hope you guys can see that. So we've got a boot application here. If I can get my mouse to work, there we go. And very briefly, just an introduction to what we have. I mentioned we have this event class, right? So it's an entity, JPA entity, and like you saw last night, Dr. Dave Sire being lazy. I like to be lazy too, so using Lombok data, making it more Groovy-like. I don't have any getters and setters. I don't have equals and hash code. That stuff's all generated for me. Very cool. I think it goes along nicely with Spring Boot. Reduce to the max, focus on what you need to do. So here we're basically defining our entity, the ID, event date, name, and location, like we saw in the browser, right? So matching onto these things, each one of these things has ID, event date, name, and location, right? If you think about that. And that's the event. That's basically it. And for the repository, we're using Spring Data JPA. Who uses Spring Data JPA? A few people, right? So basically allowing you to write repositories just by specifying an interface, magical finder methods as well. So in this case, we're just extending the JPA repository from Spring Data, saying that we want to have a JPA-based repository and get all of the nice CRUD operations for free. So that's it for repository layer. Service layer, we have an event service as an interface. Pretty straightforward. Basically just here in order to allow us to have transactional boundaries and security defined at the service layer. Otherwise, not really doing too much in this particular simple application. Event service, transactional service. There, I mentioned before, you might see add alias for. So this is a custom annotation, right? So it's got transactional on it and service on it, and uses this alias for stuff. So we can do cool things like at transactional service, read only equals true. And again, you can make stuff like this on your own. So we're just using the repository. Nothing really complex here. We do, however, have some pre-authorization spell expressions there for Spring Security integration, making sure that only admins can save and delete events. So we've got the domain, repository layer, service layer, and the web tier. We have our events controller. So this is handling the Spring MVC stuff, so the HTML-based stuff, right? So we got some get requests for slash, just displaying all of the events. Get for the form, displaying that form, and then we have a post to the form that's going to process the form that we saw in the browser a few minutes ago. Similarly, we have a REST events controller, REST controller mapped to /events, and then we have these kind of playing around with the new annotations just to give them a spin. Get JSON shows all the events, get JSON /ID, gets event with that particular ID, and then we have post JSON, put JSON, and delete resource for other RESTful interaction with the events resource. So the security is there as well. I won't get into that too much. Spring Boot, one central class, right? So we have our application class using the Spring Boot application annotation. New features as of Spring Boot 1.3 M5 maybe. Scan-based package classes, so you can specify which packages should be scanned. And if you were to look at the code there, you see this is also annotated with that alias for, just to give you an idea of how the framework also makes use of these aliases with annotations. So that's the whole code base basically there. And then for testing, if we wanted to look at this test config, let's take a look quickly at the test. So we have IT stands for integration test. You might be familiar with that. We're extending the transactional support for JUnit just to have easy access to some of those convenience methods there. Not required, but something I do from time to time. And as I mentioned, we want to use Spring Boot. We want to have the power of Spring Boot. So we're using Spring Application Configuration Annotation instead of Spring's context configuration. And if I were to, let's just do an example here. If I can type, sorry about that. Is it not gonna, application? Did I type that wrong? Something seems to be going strangely here, doesn't it? Does anyone see what I'm doing wrong here?
It's not in the same package, so you have to.
Yeah, I tried to just, it's really weird. But Control-Shift-O, it's also not doing it. No, okay. So, using Spring Boot, specifying our runtime production Spring Boot configuration, and basically auto-wiring in the repository, right? Getting that bean out that Spring Data JPA picked up for us automatically and actually implemented for us. And then just writing some simple tests against find all, find one, et cetera. Nothing too impressive here. You can check out the code if you're interested. But what I want to show you is how long this takes. That took 6.2 seconds. And you might think that's quite a long time, yeah? Right, so I think that's quite a long time. If we're just running repository, in-memory, embedded database, there's something strange going on with my IDE.
That's the demo syndrome.
This is yes, this is not supposed to be happening here. There's nothing wrong with this. Thanks. Okay, good. More eyes, better than 2. So this one ran in 3 seconds, right? So twice as fast. It's still using some of the Spring Boot stuff, but it's not using everything. So what is the everything that was causing the problems or making me less happy because it took longer? So if we look at the Spring Boot application annotation, if we take a look at that, we see it's annotated with, right, @enable auto configuration and component scanning. So it's going to scan everything, and it's going to auto-enable everything that happens to be on the class path. But for this particular test case, I decided I don't want that. I just want to test the repository layer. I still want to use boot, but just focus on the repository layer. So my solution for that was to come up with my own dedicated test config that I can reuse across all of my repository tests. So hopefully you can see here. So it's just an @ configuration class. Just to show you, I'm not using @enable auto configuration, commented out there. But then I figured out what are the parts I need. I want to enable JPA repositories, so Spring Data JPA, so that it creates my repositories for me. Specifying where to start scanning for that explicitly. Also the entity scan annotation from the Spring Data JPA support there, saying just look in that one particular package. And then import, that's the trickier part. You need to figure out which auto configuration parts of Spring Boot are what you need for that particular testing scenario. So you might want the security stuff, you might want the web stuff, you might want just the repository stuff. In this case, I wanted it to create the embedded database for me, just like it does when I deploy the application using the data source auto configuration, and also wanted the Hibernate JPA support that it was doing for me automatically, but now I'm just being very explicit saying, please set up these 2 things for my repository-based integration tests, and we see those tests run at least twice as fast, and you can maybe even fine-tune a bit more there.
So it's not true what Dr. Dev Saya said yesterday. I don't know, it's magic. You still have to understand some stuff.
That's a very good point. He was being very cheeky there. So there's a lot of magic, and a lot of times you have to actually figure out what the magic is. You can run it Spring Boot in debug mode. You can check out the endpoints there with to see which auto configuration is actually running. Check out the documentation, but it's useful to figure out which ones you need. This one's a very useful one. I've copied and pasted this in a number of places and also shared it on Stack Overflow. So that's, for repository layer, I think that's probably the best configuration for Spring Boot there. So that's it for boot. I've lost my thingy clicker. All right. So Spring Security. Yeah, and if anyone has any questions, just ask, or we can chat up later on between sessions, etc. So Spring Security tests, very cool. In the past, you would add hard code a lot, but recent additions have added first-class testing support for Spring Security. So there are a number of test annotations you can use. These are enabled and supported via a test execution listener. So the test execution listener, or TEL API, is basically a way to add additional functionality to Spring's testing support. That's actually how all of the dirtiest context stuff, dependency injection, transactional support, SQL annotation, all that stuff's with listeners. Spring Security has its own listener as well that supports these annotations. So it sees these things on your test methods, and then it does whatever you ask it to. So for some examples, we have with mock user. I'll show you an example in just a second on that one. So you can basically say, when this test method is executed, I want Spring Security's testing support to set up a user with these roles, with these authorities, stuff like that. So that you can see if invoking this method in the service layer, or invoking this REST endpoint that requires a certain user, like an admin, then you can make sure that that works. With user details, that's if you need more detailed information with the user details type in Spring Security, or if you want to configure the security context from Spring Security on your own, you can also do that with some factories, etc. So I'll let you look all that up in the reference manual there for lots of examples, but I will show you in a moment this with the with mock user. Going beyond that, so one thing to point out here, these annotations work whether you're just invoking stuff in your service layer. If you have a transactionally proxied service component, like a user service, that works fine there. Also works, again, if you're invoking REST endpoints via Spring MVC tests and stuff like that. However, if you're just using, oops, what happened here? Spring MVC test, and you want to have maybe more fine-grained control over what kind of user you want to have logged in for a particular request, you can actually do that with things like the apply Spring Security. You can add that and then you can say, you have a bunch of options there. User or authentication, security context, HTTP basic, passing in the username and password, all this kind of stuff, all well documented in the Spring Security reference manual. You can even do some cooler things like performing form-based logins. So out of the box for Spring MVC test, right, you get stuff like standard HTTP verbs, get, put, post, delete, these kind of things. But now with Spring Security, you have form login, you can run some requests there, and you can also perform a logout and verify that everything works the way you would expect. So now I will show that example there.
Or not. Or not.
We go till noon, yeah?
Yeah, for 30 minutes.
You think so? Go quickly.
Okay.
So which one was I talking about there? I said this one, no? REST events granularity. Can I not find it? It's not working, huh? So now we have a REST events controller integration test here. Again, Spring Boot configuration there. We're using the full configuration there, so end-to-end basically within Spring Boot. And web app configuration, so we're not actually launching the embedded Tomcat server. We're doing this all in container basically. Outside of container, but in Spring. So we have our web application context loaded in, mock MVC, setting that up like normal, but now just saying and apply Spring Security. So setting that up within Spring MVC test. And then we see on our normal methods like our get requests, we don't need to have a particular user. Anyone in the world can access these URLs. But for the create, as I mentioned before, we're requiring that an admin user be logged in. So we have this, if I comment this out and execute this method, hopefully it will fail. We'll see. That's the theory. Yes. 201, we got a 401, so not authorized basically, right? So if we add on the annotation and rerun the test, that should pass. Indeed it does. And the other option I wanted to show is that if you have multiple steps, for example, that you're executing within this test method, and for a particular request, for a particular post or get, you want to set a different user, something like that, then you can use these features. And that's going to have to user details. Oops. Yeah. Okay, so now we're using this, the with features from Spring MVC test, and then this user is from the, as we see here, from the user request post processor from the Spring Security test module. So then we can specify a user with a name and roles. So again, running the test again, this should also pass. So really powerful stuff, easy to use. You have the options if you need it. Easiest way is just to go with the annotations and see how far you get with that. But basically we see that we had security correctly configured, that no one can access these URLs without having the right credentials. And very fast in the test, I would say. So, testing tips and tricks. Just to start off, a few tips that I like to give people, oftentimes in my consulting role, especially when I have to sit next to somebody and watch them hit keys over and over, and I get, sometimes I lose my patience and encourage them to do things. So I encourage you to think about stuff like this. Key bindings in Eclipse, one really cool thing. Actually, a Spring guru taught me this many years ago. So I don't know if you've ever tried to type Alt-Shift-X and then wait a half a second and then hit T. That's really not very efficient. Coolest thing that I know to do is change the settings. So if you open up key bindings in the preferences for Eclipse, you can go into key, you can search in the little search box there and type in JUnit. You'll see there's two options. There's a run JUnit and a rerun JUnit. Assign that to something that's fast for you. By default, Control-J and Control-Shift-J are something like incremental search in Eclipse, but I don't care about those. So J sounds cool for me. JUnit, I'm really fast. You probably saw me. I just hit Control-J. I don't do right-click run as or Alt-Shift-X-T. I just do Control-J, and if I go move somewhere else, Control-Shift-J, maybe I'm editing an XML file and it reruns a previous test. So really cool way to speed up your productivity. Another thing, you just saw me hit that as well. I hit Control-Space with that user thing, right? So from Spring Security Test, I have no idea which class that's actually in. What I do is I set up static imports in my favorites, so Eclipse preferences, search for fave, F-A-V, and you'll see you have some options there. In testing, I'd recommend stuff like whatever your assertion framework of choice is, your JUnit or your assert J, which we use in the projects here, Mockito, stuff like that. I've got these Spring MVC ones there listed as well, and the one I just used there was the one from Spring Security. So figure out the things that you are importing a lot or wondering, oh yeah, there's this content static method somewhere. Instead of trying to figure out where it is, just add it to your list of favorites. Next up, context caching. So a lot of people don't understand that the TestContext Framework in Spring actually caches your contexts between tests, between test methods, between test classes, and also between any tests in the same test suite or the same process. So basically behind the scenes, the application contexts that are loaded in the testing framework are stored in a static map. And that can be really good if you know that it's there and you keep this in mind. You can make your tests run faster by reducing the number of the application contexts that you have loaded. But you can also run into problems if you have individual developers creating special contexts and adding in one special bean here and one special bean there and importing the other stuff. Then you just kind of have an explosion of application contexts. You can run into memory errors, issues in your test suite, and some other things like that. So again, too many, it leads up to too many contexts, but too few constellations or different ways you're configuring application contexts can result in all tests using the same config. So if you end up doing everything full-blown Spring Boot and saying, we are going to have one application context for our test, and that thing takes 20 seconds to load, then you're going to be hating yourself actually when you're trying to be productive. So that's why I say you basically want to have one set of test configuration per use case or per layer. That's why I have that one dedicated one for the repository layer, and then I have another dedicated one for doing kind of the end-to-end MVC through the service layer, through the repository layer, et cetera. Optimum use of the context cache, right? So avoid frequent use of dirty context. In an ideal world, as we heard before, code smells should be avoided, so actually you should try to stray away from dirty context, but use it sparingly if you find that you actually have to. cache statistics. So I've had to assist a number of customers who had the problem of having too many application contexts, but asked them how many do you have, what's going on, they're like, I don't know. Who knows? Maybe you could guess or something. So to help solve that problem, in one of the recent versions, 4.1 something I think, added in support for logging the cache statistics. So if you set the org Spring Framework test cache category to debug and run your tests, your entire test suite, then you'll see that all logged out. And if the number of contexts goes up into the hundreds, then you should probably rethink how you're writing your configuration. Also, if you see lots of hits and misses, and that means that you have dirty context too much, because then you have things getting removed from the cache and then recreated, right? So keep these things in mind. I mentioned this before, just as to recap, integration tests, Spring Boot versus Spring Core. By Spring Core, I mean the Spring Test support, basic support. Spring Application Configuration, again, that's going to give you the boot magic. It basically does the same thing as that kind of configuration in Core Spring. And then with Spring Boot, keep in mind things like the @enable auto configuration versus doing something handcrafted like I showed you with the test repository config. So just make sure you're testing as much as you need to, but not too much, and not making your tests take too long to run. So, Monsieur.
Yeah, so when you design your tests, also you have to think about something very interesting. It's the scope. So what is true for the configuration is also true for your classes. Basically, when you run unit tests, you don't care about the scope, because probably the scope is a unit, it's a class, it might be even the method. Whereas when you integration test, then it can be as small as 2 classes collaborating and as big as the entire system. So you have different sizes of integration tests. So you've got this new concept when you do integration testing is a SOT, and the system and test. So it can be as small as 2 classes, as big as the entire system. The point is you should respect the pyramid hierarchy, meaning that the larger the system and the test, the smaller the number of tests. So atop the pyramid, you should only test for nominal scenario. You probably took care of every details at the basis. And of course, like you do in unit testing, you have to mark the dependency of your system and test. But then you've got a new problem because some stuff cannot be marked. For example, okay, that's easy to test your service layer when you mark your repositories. But how do you test your repositories? You cannot mark a database. So that's why you use embedded database. That's called fakes. And they require setup. So when the system and the test encompasses the whole application, then it's end-to-end testing. The problem with end-to-end testing is that it's very brittle, meaning since you are testing from the web layer, then you need to click on a button to fill in fields and stuff like that. And there are not many ways to do that. Probably, if you use Selenium, for example, you will either use IDs or XPath. If you use IDs, I can bet anything that at some point, some front-end developer will remove the ID or change it for no reason. Because just, oh, he needed it, and he didn't know you used it. And as well, if you use XPath, your XPath expression should be very upgradable, because the things that change the most in any application is the UI, because the customer will say, oh no, this button, I don't want it here, I want it in the top left instead of the right, bottom right. So in this case, if you use Selenium, you should make use of the page pattern, meaning you should decouple a view of your page, so I select the button, and the fact that you click on the button. Most of the time, what you do is, in the same line, you select the element, and then you apply the action on it. Now, please separate it. Then, if something changes, you will just have to change the view of the page, not the test itself. So apart from brittleness, you have very different challenging for integration testing. You have speed, and you have diagnosis problem. So when the test fails, how can you know what it is? So the stuff, as Sam showed you, the integration tests are slower. And even if you use Spring Boot configuration, they are even slower. So that cannot change. By essence, they will be slow. You will use a database. You will use a remote web service. You might use anything you want. They will remain slow. So in order to cope with this limitation, you should at least try to segregate between unit tests and integration tests. Why? Because what is the point of trying to execute your integration tests if your unit tests are failing? So fail fast. So segregate between unit tests and integration tests and execute the unit test before the rest. So that's why if you are a Maven user, you will be very happy that there is a plugin called the failsafe plugin that does it for you. There is a small configuration, of course, but by definition, unit tests will be run into the test phase, and unit test ends with test, start with test, or end with test case, and integration test will be run into the integration test phase. So Maven already has a lifecycle that provides you with the tool to do that. Now, who uses Gradle? Okay, so you should already use Bazel because Gradle is already out of date, sorry. Gradle, you have to hack it yourself. I'm sorry, Gradle doesn't have this concept of integration test out of the box.
But if you're interested to see how to do it, the Spring Events example application has that configured. So we have segregation between unit tests, integration tests. It also shows you how to use JUnit and TestNG at the same time. Another point there, key to me what I like to have with Spring's build, that I like to see the JUnit tests and TestNG tests aggregated in terms of the reporting so that I see them side by side in the official Spring builds. And there's also an example in there of how to aggregate test reports. So just check out the build for Gradle in that application.
Integration tests also have a bigger scope. So when something breaks, the real problem is, okay, but where did it break? And so if you have a very large system under test, and you have a scenario, and I love the e-commerce scenario, meaning, okay, I want to test that my customer journey, okay, my customer goes in the store, it picks an article, it puts it in its basket, and then it goes to the checkout page, he validates that he wants his articles, and then he pays. And that is typically an integration test. This is a scenario that encompasses many pages. So this is really a good target for that. And then if in this scenario something breaks, where did it break? You have no idea. And what I suggest you to do in this case is to have small methods. And then you have, for each step in the checkout scenario, you have one method named semantically. So I have OK, then the customer browses the shop, and the customer adds something to his basket, and then if it breaks, because it will break, I mean, the tests are done for that, then you know in which method it broke. So you directly know where to check. And that's why I love TestNG in this regard, because then it's very easy to order the test methods. So, last point, brittleness. Integration tests depend on something which don't exist in unit tests. They depend on infrastructure. The first brick is, of course, a database. You know, that is all legacy stuff. Every application needs a database, even today. But now you have even more challenges, because you might depend on web services. You might depend on the file system. You might, if you do batch stuff, you might depend on the time, and so on and so forth. And this kind of stuff cannot be mocked, so you have to provide fakes for that. The problem, if you don't fake them, so let's say that you want to use a real Oracle instance or real web service, then they will not be available at some point in time. That's a given. So in this case, what happened is that your tests regularly fail, and then some nice developer will check and say, oh, but it's a web service that is unavailable. And what happens at some point, the test gets removed because you don't trust it. So fake your dependency. Make your test as independent as possible from your environment. So when it breaks, you know it's your code. You know it's not a dependency. Regarding databases, because that's a very widespread example, my first reflex would say use a schema per developer, if you can. If your database, if your DBA loves you, it will give you plenty of schema. You can have one schema per developer. That's very good. That's the better stuff you can achieve. If you cannot, then use an embedded database. In this case, I would think that H2 is better because H2 has compatibility modes. So it reduces the gap. If you cannot, then use anything you can. But just be aware that there will be a gap between the real production mode and the embedded database. So you have to know it. Regarding web services, they are very also widespread as dependencies. And basically, you've got two nature of web services nowadays. SOAP, yeah, I'm sorry, SOAP is still used, especially if you're working for a big shop. Then you can check about SOAP UI. The good thing about SOAP UI that not many people know is that it has a real API. So you can design your web services, you can design your fake response, get the XML, and then put it into your integration testing scenario, and then run it through the API. There is a runner that lets you make up a fake web server that will respond to this, to calls. If you are happy enough to use REST-only web service, then there is something very lightweight. And in this case, what I do is I use something called Spark. And Spark, as you can see, is very easy. Provided you've got the right static imports, you set the port that you want to run to, and then you say, OK, when I receive a get to hello, I return hello world. And this is nice Java 8 Lambda. So in, 2 lines of code, no, 3 lines of code, I created a fake web service. So think about it, it's good.
I'd like to add some quick points there. Actually, the Spring MVC Test Framework was originally inspired by the testing support from the Spring Web Services project, which is the SOAP support in Spring, right? So sister project. That has support for mocking your web service endpoints, right? So that your client, your web service template in Spring Web Services can invoke that. So that's actually basically mocking the SOAP web service like that. And for mocking the REST web services, we didn't look at anything like that today, but there's also support for that in Spring MVC test. So we looked at the server-side stuff with mock MVC, but there's also a way to have the mock service, so you can do the same thing with Spring MVC. And another thing he mentioned that I really liked a lot, using Java 8, I wanted to say that earlier. Actually, if you can upgrade to Java 8, for example, in Core Spring, we build against Java 8, and everything's compatible with Java 6, but in the testing suite, we're allowed to use Java 8. And I've seen myself personally and also other developers, we've started using features of Java 8. You can actually have better, more efficient, easier to understand testing code just by switching to stuff like streams and things like that. So I would say that's another tip. Use Java 8, even if you can only use it in tests. Go on.
Also, we run into this little problem. You have your app running in your development environment, then it goes to production, your number of users increases, and then, the ops calls you and tell, oh, you know, your app doesn't work anymore, there is timeout. Why timeout? Yeah, timeout, we cannot get a connection from the data pool. Okay, so you know about the story. Normally, Spring should handle everything, but at some point, a newbie comes into the development team and forgets just to release the connection to the data pool. That's a very common story. You might want to detect this kind of problem as early as possible, not in production. So in this case, if whatever database you use, embedded or not embedded, in development environment, you should set your number of max active connection to the data source to 1. So if you don't release it, then you will know it as soon as possible. So that's a nifty trick that I encourage you to use. Also, as I said previously, tests are meant to fail. That's your security harness. So when your tests fail, what you really want is to understand why it failed. If you don't understand why it failed, you are in deep trouble. If the test that fails involves a database, you want to see what's in it. It's a requirement. For that, you should override Spring default behavior in testing that says, OK, I will roll back everything. So you should commit what you do in your tests to the database. So that means that, of course, you are not running your test in production. Huh? OK, you have a dedicated testing or development environment for your database. So the first thing is commit. The second thing is use a clean startup scenario, a clean setup, meaning you remove the data before the test, then you do your stuff, and at the end, you do nothing, so that your data stays in the database until the next run, so that if a test fails, you have your data in the database. There are other strategies like clean tear down, meaning at the end of the test, you remove everything, and then you've got no trace of what happened. And finally, my recommendation would be not to use a memory database, because at the end of the test, the JVM ends as well as the data. So use a file-based database, and H2 as both. So you can use memory if you need to be very fast, and file-based if you need to check what happens afterwards. And my final recommendation, please, testing is about return over investment. It's about money. I see too many. Before it was, yeah, just push to production, and nowadays it's more like, yeah, I have the biggest coverage. You know, my code coverage is bigger than yours. Sorry, girls. So, no, it's not about that. It's not about who has the biggest code coverage. It's about, in your context, what is the consensus? What is the best deal that you get out of your tests? So think about it. It's really context dependent, though there is no right answer to that. But yeah, you don't want to have 0, and you don't want to have 100%.
So,
and now about JUnit Lambda.
JUnit. Everyone attended the keynote last night, right? I hope so. They saw a bit already from Jürgen. So basically, I just encourage everybody to give back to the project that's given so much to us. Talking about JUnit here, so it is the de facto standard testing framework in the Java ecosystem. It's actually the most used framework. If you see some studies on GitHub and stuff like that, so the most used libraries, JUnit is by far used by more projects than any other project. Of course, TestingG is also in the top 15 or something, but Spring Test is higher than TestingG, so sorry about that too. So the last major release was 10 years ago, right as he mentioned, so basically getting on board with what TestingG, or where TestingG had paved the way with the annotation-based approach. And since then, there have been new features added, like the rules were added later on, stuff like that. But there's still a lot that needs to be done. So actually things have changed quite a bit in the past 10 years. More recently, things like Java 8, people want to use stuff like lambdas, have other options for how they construct their tests, how they write their assertions, these kind of things. These are things that JUnit could profit from, but nobody's had the time, right? It's one of those open source projects where there's just a few core guys who've been doing it in their spare time over the years, but no company actually backing it up. So introducing JUnit Lambda, that's the name of the campaign, basically the push towards Java 8 Lambda support, more than likely be called JUnit 5, right? So coming up after 4.12, which is out now. And that's online now, you can contribute. So we ask you to pitch in if you can, help spread the word, tweet about it. At JUnit Lambda is the Twitter account for JUnit. You can also go to junit.org, click on info page there, or go straight to the campaign here at Indiegogo.
Yes,
So,
please make JUnit as cool as TestNG, please.
it's not quite like that. But yeah, TestingG hasn't been upgraded really too much either, so in terms of Java 8 support and stuff like that. Anyway, so JUnit Lambda, as we heard last night, Pivotal is in fact supporting the campaign. Many other companies are as well, so we hope that you can at least help spread the word. So in closing, I just like to always mention Spring resources. Hopefully you know they all are. If you don't know where to start, go to spring.io, right? So you can find the projects page there for Spring Framework, boot, security, and everything else. The guides, great place to look if you want to get up and running very quickly, better than your standard tutorials. Jira if you find any issues, so if you find a bug, there are bugs, they do exist, or if you have recommendations on new features and stuff like that, spring.io, Jira.spring.io for that. Sorry, this is not working through the tables here. We got GitHub, of course, all the code's up on GitHub. Check it out, fork it, pull requests, you're welcome, stuff like that. And Stack Overflow, so no forums anymore. If you have questions, just use any of these Spring Dash tags to get in touch with the community or answer questions yourself. Blogs, there's of course the official blog from Pivotal. This is really not working well. Sorry about that.
I didn't touch anything.
So the official Spring blog, right? Spring.io/blog. You can check out my company blog or Nicolas' blog as well. And last but not least, if you want to get in touch with us, again, my name is Sam Brannen. You can follow me on Twitter at Sam_Brannen. I post slides on SlideShare under the sbrannen user account, and my company SwiftMine.com. And Nicolas, you can also find him as well on Twitter. So we'd like to thank everybody for coming. If you have any questions, we'll hang out and you can ask us later, but I think we're closing up now. So thanks.
Thank you.